Okay, here we're going to look at the distributive property. The distributive property is one of the more popular properties in algebra, meaning you will use this over and over and over again in this class, in geometry, algebra 2, college algebra and beyond. This will be something you know well. So it's an important day. We're going to first look at this geometrically or kind of visually. So this might be hard to get. If it is, that's okay. But remember, when you find the area of a rectangle, you do length times width. So you could look at it as one big rectangle. So if this is one big rectangle, then it's 3 times x plus 2, the length times the width. And that will give you the area. Or you could think of this as 2 rectangles. You could think of this as, if this is 3 and this is x, do 3 times x, and then plus 3 times 2. And it gives you the area. And those are equal. And so, in other words, this 3 times x plus 2 is the same if we multiply or distribute the 3. 3 times 2 is 6. So these are the equivalent expressions. Get a definition for equivalent expressions. Let's write this down. They are 2 expressions, or I guess it could be more, 2 or more expressions that have the same value for every value of the variables. So if 2 expressions are equivalent, variable or variables, then no matter what you plug into the variables, you'll get the same number or same value. And so it's just a different way to write an expression. Okay, so here's the distributive property with a bunch of math symbols, and this is probably pretty confusing, as most math definitions are. Pretty hard to look at. So if you look at that and it makes sense, great. So A times B plus C is the same as AB plus AC, but it's just kind of a lot. But you should pause the video, work your way through this. We're going to look through these examples to kind of show you what those definitions mean. So watch maybe 1 or 2 of these and then try these on your own. When you use the distributive property to write D there, an equivalent expression, that means just to multiply the number in front or behind the parentheses. Typically, you won't see this. Like, this is atypical in math. Normally, we move the 9 to the front because remember, with multiplication, order does not matter. But what we do is multiply both terms. So we get 3x plus 3 times 6, or 3x plus 18. And then go ahead and pause the video and try these on your own, and then check your work. Here we can distribute and watch the signs. You get 72 minus 9x. Here, if they're variables, if they're not the same, they just go next to each other. Typically, you write the first, or the letter that comes first in the alphabet first. So mx plus my. Here, watch your sign. -3 and m times m is m squared. So -3m squared, and then plus 15m, because we have a negative times a negative makes a positive. If there's just a negative sign, what you're really distributing is the -1. And what's happening is the signs are just going to change. So this will be -4 plus y. And you would normally see that, which is correct. You would probably see that as y minus 4. So those are the same thing. And then fractions don't change anything other than we have to work with fractions. But it's distribute, and you get 2n over 2, which will reduce, and then 6 over 2. Remember, with fractions, you multiply straight across. You can think of the 1 being underneath each of those terms. And then reduce. So 2 over 2 is just n, and then plus 3. Okay, and we've used some of these words already, but the terms referred to, we'll circle those in blue. This entire thing is a term. So there are three terms here. Negative x is a term, 2x, which we don't say positive, it implies it's positive, and then 8, or positive 8. The coefficients are the numbers in front. So coefficients would be -1, 2, and there's no coefficient on a constant, as we call it. So the terms, and we'll just kind of do loose definitions here. The parts, or the terms, are the parts that are added or subtracted. Coefficient is the number in front of the variable. Constant term is just a number, or it has no variable. So if it doesn't have a variable, it's going to stay the same. 8's going to always be 8, no matter what you plug in for x. And then like terms are terms with the same variable and exponent. And that's kind of an abbreviated way to say that if the variable has the same exponent, then it's a like term. So in here, the terms are -2x, -8, 6x, and 5. Like terms, -2x, let's circle or underline those. -2x and 6x are like terms, and -8 and 5 are like terms. The coefficients are -2 and 6. The constant terms are -8 and 5. Oh, okay, you can see that. I thought that was off the screen. Okay, so here when it says simplify the expressions, what that means is first we are going to distribute. And then we're going to do what we call combine like terms. And this is a very important skill in algebra. You will do this a lot. When you combine like terms, if you're just adding or subtracting, the variable does not change if there happens to be a variable. You just add or subtract the numbers in front. If you think you know how to do this, go ahead and pause the video and try these 5 problems. And if not, watch 1 or 2 and then pause and try the rest on your own. So here's 6y minus 1y. And there is a 1 there, you can write that, would just be 5y. Here we got to distribute first. So distribute the 2, and you get 8x minus 2 plus x. And then our like terms are 8x and 1x. And so that's 9x minus 2. You cannot make this 7 because this has an x and this does not. So they don't go together. They're not buddies. They're not friends. Here we have to distribute the negative, and this one's always kind of tricky, but it's distributed in -1. So that's 4p minus 2 and then plus t. And then there's nothing else you can do here because we have p's and t's. They're not the same. They don't go together. And so you can just leave it like that. Sometimes what we'll encourage you to do is write the constant last, so all the variables come first. Here, make sure you distribute the -4, so it's -4x plus 8 minus 7. And then -4x, there's no other x's to combine, so you can't do that at all. But I can add 1 because 8 minus 7 is 1. So let's underline those like terms. And the last one, if you haven't paused the video and tried one of these on your own, please do right now. Distribute the 3. So that's 3m plus 12. Distribute the negative 2. So that's negative 2m plus 2. And so notice you only distribute to the parentheses that it's directly in front of. You don't take the 3 all the way over to here. And then combine like terms. So we have some m's that go together. 3 minus 2 is just 1m. And then we have 12 and 2 that are both constants. So they go together, or just numbers, to make 14. To help you maybe visualize this a little bit, if you think about like, well, so this is 3 m's and then minus 2 m's. Well, think if you had like 3 m's in your hand and then someone took away 2 m's, how many m's would you have? You would be only left with 1 m. Or think about something else than m's. Think about like apples, think about, or it's m, maybe mangoes. So if you had 3 mangoes in your hand and someone took away 2, how many mangoes would you have? You would have 1 mango, but it's still a mango. So you have 1 m, but it's still an m. It hasn't changed what it is. There's just the number in front of it has changed, or the number that you have has changed. This is not easy necessarily. It's kind of difficult. So if you have questions, please reach out. It's also, like I mentioned before, it's very, very important. So please reach out if you have any questions, and good luck.